Hello, my name is Thomas Smith, and I'm here to teach you guys today about SCF Performance Standard number 11. This performance standard has to deal with hypothesis testing, which, to be honest, there's only one way to teach and only one way to learn hypothesis testing, which is through examples. But first, you must familiarize yourself with the 4 steps to hypothesis testing. This is their formal name. These are the 4 steps right here. You should have this written down if you are this far, but if you do not, feel free to pause, rewind, go back and write those down right now, because that is what we need to do. That is what you will need for every hypothesis testing question ever in your life. You will need to know these 4 steps 100%. Alright, next thing, best way to do it again, just through examples, so we're just going to have to jump right into one as of right now. I'm just going to read a question, and every aspect of the question is very important, so I'm going to recommend that you rewind and, as I speak, try to talk kind of slowly so you get everything and make sure you understand it all. But feel free to rewind and make sure that you have everything written down exactly, because it's a lot easier to do when you can see it handwritten or typed out. Alright, so real fast. Your question is, the direct mailing company sells computers and computer parts by mail. The company claims that at least 90% of all orders are mailed within 72 hours after they are received. The quality control department at the company often takes samples to check if this claim is valid. A recently taken sample of 150 orders showed that 129 of them were mailed within 72 hours. Do you think the company's claim is true? Use a 2.5 significance level. Okay, so first things first, referring back to the 4 steps of hypothesis testing, we have to decide our null hypothesis and our alternative hypothesis. And it's very simple in this case. Null hypothesis is basically, what are we trying to test? What is the company saying? That's what we're trying to find out is true or not. The company's saying that at least 90%. So basically they're saying that 90% of their orders are all mailed within 72 hours. So what you have to do is just write down under null hypothesis P equals 0.9. Since it's 90%, you're just going to use decimals, so 0.9. And then for alternative hypothesis, you're going to want to write down P is less than. P is less than 0.9. Because they're trying to test, the quality control department is trying to test whether or not, basically to test that it's lower than 90% to make sure that their claim is true. Alright, now you also write down the significance level, which they said is 2.5%. Divide that number by 100 so we can make sure that we put it in a decimal, more of a decimal form, so it as actual percentage. So it's going to basically be significance level equals 0.025, so 2.5%. Then next step, fun one. We have to decide what test we're going to use. This can be very simple. It's basically trial and error. I'm going to show you this right here as a little quick example. You're going to want to turn on your calculator first. I'm getting ahead of myself. Then press the stat button. And then after you press the stat button, you're going to be at this screen right here. And you're just going to arrow over 2 times the test. And you're going to look. For hypothesis testing, it's going to be test number 1, test number 2, or down here, test number 5 are going to be our only options. So let's just do trial and error, make sure that everything we have is there. Okay. So for z-test, press enter. And you look, see right here, you can tell right away that right there, that's a population standard deviation. We don't have that in this equation. We don't have a standard deviation at all. So that's how you know, bam, right there, the z-test is out. T-test, look down. Again, standard deviation, we do not have one of those. It is too much information. So now what we must do is go down to test number 5, press enter, and if you look at that, we have our p-value there, we have our x, our n, and then we have our proportion and everything. Okay, so basically for the p-value, or not the p-value, but the null hypothesis, sorry. It's 0.9, so that's what you put for that PO. It looks like a P with a small O next to it. You put 0.9, very top line, as in 90%. And then our X is the number we're trying to deal with, which is 129, because that was what the little sample test that they had. It was that they talked about in the equation. 129 of them were mailed out of 150 out of 72 hours. So that's why for N under X, it's going to be 150, because there's 129 out of 150, which is where X equals 129 and N equals 150. I hope you could follow that. Okay. And then for the last one, you can select between doesn't equal, less than, or greater than. Or, I'm sorry, greater than or less than. Due to our alternative being less than, that is what we're going to choose for the middle one. And so before I press calculate here, that is what you want your thing to look like. That is exactly how the screen needs to look. Go ahead and, again, pause it right now if you need to. I'm taking it away. Alright, now just press enter on calculate. And right there, it gives us our next one, which is the p-value right here. That is what we need to write down. 0.051. That is what we need. Usually we only round it to 100th place, but round it to the thousandths because the significance level had to be rounded to the thousandths due to it being such a low, because it was 2.5%. We had to round it to the thousandth place. So again, just round the p-value to the thousandth place instead of the 100th, which is what we normally do in class. So for p-value, again, write down 0.051. That's what we need. Okay, now what you have to decide is the p-value greater than or less than the significance level? I believe that we can all agree that 0.05 is greater than 0.02, which means that our p-value is greater than the significance level, meaning that we fail to reject. Fail to reject is basically the same thing as saying we accept it, but in statistics, we're not saying that's necessarily true, so they say fail to reject instead of accept. I guess it's safer to say that, but because your options are reject or fail to reject. So in this case, we just say fail to reject because, again, the p-value is greater than the significance level. Now, last step, very last step, and we are all done with this example. We have to take our conclusion, which was fail to reject again. We have to take that and then put it in terms of the problem. I have right here written down, we can now conclude that the machine does not need adjustments. So basically we're agreeing with the company. We have to assume that what the company says is true, that 90% of all orders are mailed within 72 hours. We have to assume that that is true, and we have to accept it, and then basically say that the company's stats and everything they have written down is 100% true, and that they're proven okay. Here's a quick little thing in case you didn't get any information, you missed anything. This is what everything should look like. I hope you can see everything well. Again, you can always feel free to just pause, rewind, playback. That's basically it. I'd recommend doing the same thing we just did there. Again, going over the 4 steps hypothesis testing and going over it with more examples. Ask your teacher for some, or you can find some online, anything, Google hypothesis testing examples. You'll find a lot of results. Yeah, I say go for it. Good luck in the future as far as statistics and all your hypothesis testing questions in the future. Good job. Good luck, guys.